In the previous clip, we learned how to find an inverse matrix, and in this clip, I'll show you how we can use the inverse matrix to solve the system of linear equations. It's just one way of solving. I'll demonstrate on an example. Here's a system, 3 equations and 3 unknowns. And we can write this system in matrix form. If we write it like this, take the coefficients of the left-hand side, put them in a 3 by 3 matrix, put the variables in a 1-column matrix, and the right-hand side, this is matrix multiplication. For example, the top element, it's the first row, first column. So we take here the first row and here the first column to get this. And what this says is that 2 times x minus 1 times y plus 1 times z is 3. That's the top row. Similarly, if I chose the second row, first column, I'd get this. And if I chose this with this, I'd get this. So this is the matrix representation. And we don't stop to think about why this is true after you've seen this. When you have a system, you just write the matrix with the coefficients on the left here, and then the variables, and then the free coefficients on the right. Okay, so how are we going to use inverse matrices, or the inverse matrix? Let me give the matrix a name, A, and we'll give these 2 names also. Remember, with vectors which have a single column or row, we use lowercase and underscore. So I'll call this x, and this I'll call this one b. And it turns out that if we have this equation like ax equals b, which is what we have, then x is given by the inverse of a times the vector b. You don't have to know why, but I'll just quickly show you. If a times x is equal to b, we can multiply both sides by a minus 1. So a minus 1 ax is a minus 1b. But a minus 1a is just the identity matrix. And an identity matrix times anything is itself, so this just says that x equals b. Okay, you didn't need to know that, but if you were curious. And I'll erase that.